Today on How It's Made. Combination wrenches. Deli meats. Golf cars. And airships. Whether tightening the wheels on your bike or working on your car, a combination wrench can make the toughest job safe and easy. The best combination wrench gives you reach and strength and won't bust your knuckles when you're working in those hard-to-reach places. A high-quality combination wrench can last you a lifetime. A combination wrench tightens and loosens nuts and bolts using its U-shaped open end or its enclosed box end with a hexagonal shape. Combination wrenches come in imperial and metric sizes. To start, a steel bar travels into a die cutting machine that cuts it into lengths called billets. Each billet will become a wrench. One by one, a machine feeds the billets into an induction heater. It heats them to more than 1800 degrees Fahrenheit, then sends them into a forging press, where the first die creates the wrench's general shape. The second die gives it its finished shape, and the third trims off the excess metal. The wrenches exit the forge press and cool off on their way into a collection box. Then a worker grinds off the trim line, a thin line of excess metal created when the top and bottom dies come together. He loads the wrenches into an automatic edge polishing machine. Using an 80-grit sanding belt, the machine grinds the trim line on both sides of the handle. The wrenches leave the edge polishing machine trim line free. A worker then places each wrench onto a 75-ton hydraulic press, which stamps it with the brand name, size, and part number. This bend machine gives the box end a 15-degree angle. A vertical milling machine then drills a hole into the box end, using coolant to keep the drill from overheating. This is a hydraulic hex broach machine. The broach tool is what gives the hole a hexagonal shape. Open-end wrenches also go through a broaching operation. In this case, the broach tool shapes the open end into the desired size. A worker then grinds the open end of the wrenches and makes sure they're perfectly smooth. The wrenches now undergo a 3-stage heat tempering procedure to harden and strengthen the metal. For some combination wrenches, a slotting machine cuts an opening out of the box end that has the hex shape broached into it. This turns the wrench into a flare nut wrench that's ideal for working on hard-to-reach bolts like on a hydraulic line. Ceramic stones and a chemical solution polish the wrenches for 8 hours, giving them a bright luster finish. A machine then dips the wrenches into a nickel plating solution that helps make them corrosion resistant. This series of baths then plate the wrenches with trivalent chrome, which is a safer, more environmentally friendly alternative to traditional plating methods. After a final rinse in water, the wrenches come out with a bright cosmetic finish. Combination wrenches are available in a variety of sets, all conveniently organized and neatly stored. Since the 1920s, this company has been making combination wrenches of all shapes and sizes, for jobs of all shapes and sizes. In a time of health-conscious eating, deli meats remain a mealtime favorite. Almost everyone loves a great-tasting sandwich or sausage hot off the grill. Today, the best deli meats are prepared from the leanest cuts. They have no trans fat, they are low in sodium and saturated fat, and contain no fillers. Some companies prepare deli meats largely by hand to maintain that old-world tradition. Sausages begin as cuts of fresh meats in a grinder. The ground meat falls into a collection tub, which then deposits the meats into a mixer. Adding ice keeps the meats cold and fresh. A worker then adds salt and all-natural spices and seasonings. The mixer blends it all together. A worker feeds a natural sausage casing into a machine called a sausage linker that forms and links the sausages. A look inside the sausage linker reveals where the meat is pumped into the natural casing and shaped into the desired sausage size. As the sausages come out of the linker, they hook onto a conveyor system. They're ready to go into the smokehouse for cooking. Workers send the cooked sausage into an oven that destroys any possible surface bacteria. They pack the sausages into plastic bags, which are date stamped. Then a machine vacuum seals the packages, making them ready for the store. An olive loaf begins with a mixture of olives, pickles, and pimentos. Again, a worker adds salt and all-natural seasonings, mixing it together with blended fresh beef and pork. This stuffer machine fills loaf pans with the seasoned blended meats. Another worker puts a rack filled with uncooked olive loaves into a smokehouse oven. After an initial cooking that sets the loaf shape, he removes the loaves from the oven. At this time, only the exposed part of the loaves is browned. After he takes them out of the pans, they will go back into the oven to brown all sides. It takes about 10 hours to cook these special European-style loaves. Another worker loads pepperoni into a machine called a revolving horn. It stuffs a casing with a mixture of beef and pork, seasoned with Italian spices. The horn stuffs the casing with a precise amount of meat and seals both ends. The pepperoni is then hung up on a rack and taken into a smokehouse for cooking. Another worker prepares German bologna by slipping a natural beef casing onto a machine called a stuffing horn. He stuffs the casing with a mixture of beef and pork and all natural spices and seasonings. He seals the end of the casing with aluminum clips. Another worker, using a paddle with spikes, perforates the casing to allow air to escape during cooking, to ensure even cooking and browning. Now it's the German bologna's turn for a stay in the smokehouse. About 8 hours later, the German bologna is evenly cooked. Using a guide, a worker slices the sausage into even cuts, which are then packed and date stamped. From authentic German bologna to all types of sausages and distinctive deli loaves, deli meats are served around the world. Scotland is the birthplace both of golf and the motorized golf car, invented in 1946 by a dentist named John Doc Keegan. Since the late 1950s, golf cars have become widely used on courses everywhere. They're built low to the ground to remain steady, even over the most uneven terrain. This battery-powered golf car has everything to get you around in comfort and style. It can't help you with your swing, but it can get you to the next hole in a jiffy. To make a golf car, the first step is to build the frame with lightweight aluminum I-beams. They go through 2 separate machines to bend them into shape. Metal forms press down into vinyl and stretch it into the shape of the front and back seats. Workers cut and staple the vinyl over a plywood base covered with a layer of foam padding. They trim away the excess vinyl and set the finished seats aside. Now it's time to assemble the powertrain. Here, workers place an axle onto the differential, which rotates the wheels. They cover it with a staff ring. Then bolt the car's 48-volt electric motor onto the transaxle, the assembled transmission, differential, and drive axle. They assemble the car's frame on a fixture, starting with the driver's side, then the passenger side, then the center I-beam that holds the 2 sides together. They set the assembled frame onto the powertrain and bolt the car's front suspension mechanism onto it. As the car moves on to the next assembly station, a plastic underbody comes down to cover the front part of the frame. Workers now set in the accelerator and brake pedal. Then they lower the power compartment that holds the car's battery at the vehicle's rear. They connect the battery to the motor with 4 separate wires, then hook them up to the electric control module that commands the engine. Now they can cover the rear working parts with a plastic underbody. The underbody provides the support on which to install the car's working parts, like this pedal mechanism or the steering column. All the electric tools that apply torque are computer monitored. If the amount of torque applied at any of the 130 assembly stations is incorrect, the system prevents the car from advancing to the next station until they get it right. This eliminates any problems that might arise with over-tightened or loose bolts. Workers now tighten the battery wires, then check the accelerator. Golf cars may not attain speeds higher than 15 miles per hour, in compliance with industry regulations. Next, they set in the front and back seats that fit snugly into the molded plastic rear body, and screw in the front fascia that covers the underbody. They set the brake rod in place, make sure it moves the brake pedal properly, and tighten it. The screen located overhead indicates when they've applied just the right amount of torque. Finally, they hammer in the hubcaps and set in the front beauty panel, also made of molded plastic. The car's now fully assembled and ready to roll. The finished golf cars offload automatically from the assembly line thanks to a hydraulic lift. They get a final inspection from every angle, even under the seat. Finally, workers drive them to an outdoor lot. No worries, their aluminum chassis ensures they can endure even the harshest weather conditions. Soon, they'll carry eager golfers across courses throughout the world. An airship is basically a large helium balloon with an engine for propulsion. The passengers and crew ride in a gondola suspended underneath. When there's an inside frame supporting it, the airship is called a rigid type. When there's no framework, it's called a non-rigid type or blimp. The envelope material is made of 5 polyester-based fabrics bonded together. It's lightweight, yet resistant to harsh weather and UV rays. The crew inflates the envelope with helium, an inert, non-flammable gas. At the back of the envelope are a rudder and fins for steering. The factory constructs each fin's frame out of tough, lightweight carbon fiber. Workers coat it with adhesive, then apply a polyester aircraft fabric, adding extra adhesive to seal the seams. Then, using an iron, they heat shrink the fabric until it's taut. They repeat this process with 2 additional layers of fabric. Then paint it white. They mount the fins to the airship envelope with a combination of steel cables and rope. The steel cables are rigid, but the rope has some give when the envelope flexes in flight. A system of cables and pulleys connect the rudder and fin to the cockpit. The pilot manipulates them with yokes. The flaps control up and down movement, the rudder sideways movement. Engineers inspect the envelope inside and out for pinholes to ensure no helium can leak out. To repair a pinhole, technicians first cover it with a piece of tape. Then brush on some adhesive in a circular pattern. They apply a circular patch made of the same 5-layer fabric as the envelope. Using a spatula, they push out air and excess glue to ensure airtight adhesion. The airship runs on 2 gasoline-powered engines. Workers hoist them into the engine bay at the back of the gondola. The propeller's sharp blades are encased in a duct for safety. 1 propeller goes on each side. The blades of the propeller pivot to move the airship in reverse without having to stop the engine. The cockpit electrical panel has gas management gauges because as the airship rises, the helium expands, so the pilot has to reduce air pressure inside the envelope to keep it from bursting. In a pinch, the pilot can also open a valve to vent helium. To test the helium valve, technicians blow in pressurized air while brushing liquid along the edge. Any bubbles indicate leaks that need sealing. The valve opens and closes with levers and cables. Unlike electronic controls, cables can be repaired in mid-air if something breaks. Inside the envelope, they install air sacs called ballonets, the gray areas in this diagram. The pilot deflates the ballonets to rise and inflates them to descend. Workers attach the envelope and gondola with cables, belts, and braces, and fill a ballast tank under the gondola with water. In an emergency, The crew can dump the water for a boost of buoyancy. The gondola also has compartments for shot bags, 22-pound bags of lead. Before takeoff, the pilot checks the weight with passengers, equipment, and fuel on board. Then the crew loads enough shot bags to balance the airship. To park the airship, they lock its nose onto a mast. Just before flight time, a truck tows the mast out of the hangar. Then it's all hands on deck. Well, actually, all hands on gondola until takeoff. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.